Here we go. Lesson 6-2. Radicals and rationals. We're mainly working with exponents during this chapter. And so a little reminder here about some ideas that might have been thought about in the past, and you're going to use this ideas in the lesson. So it's good to kind of look back and be reminded. So what number times itself 3 times will give it me negative 27? And you could start with things like, I'm going to say negative 5. But if I take negative 5 times negative 5 times negative 5, I get negative 125, and that's way too small. I want negative 27. So we say, okay, let's try something other than negative 5. Maybe negative 4. And that gets us negative 64 on our calculator. And if we tried 3, again, pull your calculator out, multiply that times itself 3 times, you get negative 27. Yay! So we know that x must be negative 3. So when we get a problem like letter B, and we have the square root of 64, that is asking us what 2 numbers multiply to give me 64. So it's kind of like the last problem, except it just wants one number times itself twice. And if you think about this, first of all, it's a positive 64, so it could be 7 times 7. No, that's 49. That's too small. 9 times 9. No, that's 81. That's too big. So 8 times 8 is 64. So my answer is 8. And again, your calculator will verify that. Secondly, if I have to do the cube root, so if I put a 3 out in front here, again, that's what's asking me some number times itself 3 times. So that's kind of like the first problem that we did, except we want it to equal 64, not negative 27. Again, trying some numbers in your calculator, you eventually realize that 4 times itself 3 times is 64. Okay? So using your calculator to verify what number you need to do. And don't worry, you won't need to be picking like decimals or those kinds of things. It'll always be a nice whole integer, as we say. First of all, a few words about vocabulary. We have, first of all, what we call radical format. Radical format. Still didn't spell that well, did I? There we go. And exponential format. So a radical is what we used to call a square root. And we'll talk a lot about this in our later chapter. In fact, our last chapter, this comes up again. This is called a radical. And if we have an exponent, then it's called exponential format. So now this number here in front of the radical, kind of in front and up high, we call that little number index. That tells me how many times you're multiplying it. All right? And a radical always asks, find a number that's multiplied by itself that many times. Again, how many times? Whatever n says, to equal that number that's in there. And we'll practice that some more in the homework. Exponential form. Well, the number that is in the bottom, right, that has the exponent, we call that the base. The number that is higher in the exponent, what we call the numerator, that's the power. And then the number at the bottom is the radical. Now, some people also refer to that as the root. So depending upon what textbook you're using, you'll use different language. So example number 1, it says simplify by rewriting to the other form. So we see that this is in radical format, so we want to write it in exponential format. So I want to write a number with an exponent power. So the big number is, as you probably would guess, 64. And then the exponent. Now, what's the power? And what is the radical? Well, the radical you can see, it's pretty easy. It's 3. That's the index that was sitting right here. But the power is hiding, and it's a 1. You recall, if there is no exponent, we can always assume it's to the first power. Okay. What is 64 to the 1/3? If you've got a calculator, I'm going to show you how to type this in. So 64, and then you're going to hit a power button, and then you can hit 1 divided by 3. Or you can just use your brain and say, what number times itself 3 times is 64? Either way, you're going to get an answer of 4. Problem 2. This one now, you'll notice, is written in exponential. We need to write it in the other format. What's the other format? Radical format. So I'm going to write it as a radical. So we start with a radical. The big number goes inside the base. And then what I want to do is I want to put a number here and a number here. This is the index, and then this is the power. So again, the power is up top, the index is on the bottom. So the 3 goes here and the 2 goes here. This problem has 2 parts to it. What do we do first? Do we do the power or the exponent? Or the index? And in this case, I would suggest you work with the index first, because this makes things smaller. Powers make things bigger. So in essence, I'm going to do the 3rd root of 125. Again, that's asking me what number times itself 3 times is 125. And the answer to that question is 5. So I've done the power part. Now I got to do the exponent part. So what is 5 to the 2nd power? So we have a 5 times 5, which is 25. So there's my final answer. Again, if you check on your calculator and you take 125, use the caret key, the exponent, and then we need to enter in parentheses 2 divided by 3. And that should also show you 125. Okay? Examples 2 and 3 now are kind of going to be variations of this. Number 1, here they've asked us to find the nth root of a. So we want to find the 4th root of 16. Okay? N is 4, a is 16. So what we're going to do is we're going to say the 4th root of 16. Again, it's asking myself, I'm multiplying something 4 times, and I want to get 16. Your calculator will tell you that if you take 2 times 2 times 2 times 2, you get 16. If you try 3, you get too much. If you try 1, you get too little. But 2 is perfect. And again, don't worry, you're not going to have decimal answers here. So here, notice example B, we have the 3rd root of negative 8. So the 3rd root of negative 8. So some number times itself 3 times is negative 8. So 2 times 2 times 2 is 8. But in this case, we need negatives to get the negative 8. Start make sense? I hope. 2 more examples. 3. 81 to the 1/4. So I'm going to rewrite and then find the value. So it is exponential, so I want to put it in radical. 81 to the first power, fourth root. Hopefully you are trying some numbers out. What number times itself 4 times is 81. Might have to hit pause here and figure that out. So whether you did that or you went to your calculator and hit 81 to the 1/4 power, either one should have given you 3. And now I've got the third root of 81. So again, I need to rewrite first of all. So 8. Now I need to write it with an exponent. So I'm going to put what number upstairs? Well, the power. The power is hiding, so it's a 1. The root is 3. When I'm done with that, I need to make the whole answer negative. So I think 2 is the third root of 8. So my answer is -2. All right. Final problem, inflation. Something that is coming up in the news a lot is that our inflation rate has been high. Lately, it's been coming down. And if you talk to people who've been around a lot, like Mr. Larson, or people who are older than Mr. Larson, and they will tell you that back in the day, we would buy a Coke for $0.25. If you know some grandmas and grandpas, they might even say, oh, we bought it for $0.05. So in the 2020s is when Cokes started to reach $1, and now they're probably more like $1.50 or $2 if you come to the vending machines, yes? Though the sizes have gotten bigger too from when we bought Coke, so they get more expensive that way. All right, we can find this inflation rate based on these 2 facts. So here's fact 1. Here's fact 2. Item number 1, okay? In my formula, to find the rate R, I need to know the final price divided by the original price. So the final price was $1. The original price was 25 cents. Notice how I didn't write 25, but 0.25. I'm going to carry that to the 1/n power. Now, what's the n refer to? That is the number of years that have gone by. So from 1970 to 2020, how many years have gone on? And most kids would say, well, subtract 2020 minus 1970. You get 50. So now I'm going to take 1 divided by 0.25. I'm going to grab my calculator. There should be some at the desk here near you. And 1 divided by 0.25 is 4. So now I need to take 4 to the 1/50th. So 4 to the 1/50th power. This is nothing that you can do in your brain. This is something that you actually have to use a machine for. All right? And my calculator says you get an inflation rate of 1 point, I'm going to say 0, and I'm going to round the 2 off to a 3. So we have a 1% inflation rate on a Coke. I'm sorry. I did that wrong. The answer is 1.03. We're going to ignore the 1. That's the 100%. And all we're going to keep is the 3 cents, the 3%. So this is 0.03, which is 3% inflation. Remember, for percents, we got to slide 2 spots. Okay? So either answer here, 0.03 or 3%, would be adequate. All right.